Hello guys, welcome back to the part 3 of the rational function series. In today's video we're going to talk about range of functions. This was the question I gave out in the previous video. We're going to solve the questions today before we proceed to the range of rational functions. But if today, or let me say if this is the very first time of visiting the channel, please subscribe to the channel. It won't take you much time, about 2 seconds to do that for me. Just click on the subscribe button for me, and yes, yeah, that is that. Let's get into today's video. Let's try to solve the previous questions, and yeah, we continue from there. Now we got three functions to find the domain of, and from the previous knowledge we're saying that to find the domain of a function, the domain consists of all possible numbers of x that is going to make the function to be defined. So we excluding all numbers that is going to make this function to be undefined. Now looking at the very first question, that is h of x to be equal to 3x plus 2 divided by root of x plus 4. Now for this function to be undefined, the denominator is going to be 0, must be 0 for this function to be undefined. But actually that's not the only thing to make this function undefined. Since we are in the real number zone, that is the realms of real numbers, we can't take the root of a negative number. So if we get any negative number under the square root, let me say negative 8, negative 9, you can't really take the square root of this number because you are not in the complex number system. We're talking about the real number system. So there are lots of numbers to make this to be undefined, not just 0. So we're saying that for this to be defined, the denominator, or let me say the radicand, the element under the square root sign, should be greater than 0. It shouldn't be 0, because if this is 0, this becomes undefined, the entire thing becomes undefined. And if this is negative also, the entire thing becomes undefined. So there are conditions. This x plus 4, that is the radicand, should be greater than 0. If this is equal to 0, the denominator is going to be 0, making everything to be undefined. And if this is less than 0, that is if it is negative, this is also going to make it undefined because we move out of the real number system into the complex number system. So to find the domain of this function, all the numbers that is going to make this function to be defined will be numbers of this form, that is x plus 4 should be greater than 0. Now you can solve this inequality and we get x to be greater than negative 4 straight away, which you can now write our domain, the domain of h of x to be equal to the set x belongs to real number system and x should be greater than negative 4. So that answers this question. So with this one you have to be very careful. We don't just equate this one to 0. I know most people, the common mistakes that most students will do is to set everything to 0, that is square root of x plus 4 is equal to 0. Now squaring both sides, we get x plus 4 is equal to 0 squared, which is 0, then x is equal to negative 4. Fine, if you exclude negative 4 from the numbers, what about the other numbers to make that is going to make this function to be undefined? You can see that this is a limited, it doesn't really enter all the solution. This is just a portion of the solution. So if you provide something like this, everything is wrong actually. So please look at the function under consideration. This is a radical function. So radical functions, you should know how to treat the domain of radical functions before you can transfer this knowledge to rational functions. So maybe sometime I'll make a video on radical functions and I'll go in depth into this kind of functions and the domain of this function, the range of this function, the curve sketching of these functions and other things. But now for rational functions, we know that the domain of a rational function should be all numbers that is going to make the function to be defined. So any number that is going to make this to be undefined, we exclude it. So there's a way to write down the solution for the first one, that is h of x is equal to 3x plus 2 all over the square root of x plus 4. This one way. There is another way to use the exception. With that one, we're going to say that, let me just clean this side to get some space. if I want to use the exception to solve this question, so we're saying that all numbers that is going to make this to be undefined, that is what I'm going to target now. I'm going to target all numbers to make this undefined. So for this to be undefined, x plus 4 should be less or equal to 0. Now I can say that x is less than or equal to negative 4. Now rewriting the domain of this, I will say that the domain of this function will be x such that x belongs to real numbers except x less than or equal to negative 4. So except x less than or equal to negative 4. I think I'm out of my screen. Let me just clean this and write it well. Except x less than or equal to negative 4. But I don't see why you stress yourself to use the exception. So the best thing to do is to just find the possible values that is going to make this to be defined, and you're good to go. Don't really stress yourself to go through all this and add an exception to it. But this is not wrong anyway. Okay, so that was that for the first question. I hope you got it correct. If you didn't, please try to do your corrections at least, so that you learn from your mistakes. Now let's go to the second one. The second one says that g of x is equal to 4 over x squared minus 6x plus 8. So for this to be defined, or for this to be undefined, then the denominator must be 0. I'm going to use the exception over here. We can use any method that we like to solve this quadratic equation. You can use the quadratic formula. We can also use the method of factorization. I think the method of factorization would be easier at this point. I'm looking for two numbers. When multiplied, I'll get positive 8, and when summed up, I'll get negative 6. And the two possible numbers can be, I think, 4 and 2. So x squared minus negative 4 and negative 2, 4x minus 2x plus 8 is equal to 0. Now I can factor out x in this two terms, so x minus 4 out, minus 2 out, x minus 4 as well is equal to 0. Now factoring out x minus 4 again, x minus 4 out, I get x minus 2. Now two things are multiplying and the result is 0. This implies that either x minus 4 is equal to 0 or x minus 2 is equal to 0. So I can continue to say x minus 4 is equal to 0 or x minus 2 is equal to 0. Solving for x is equal to 4 or x is equal to 2. I can now write my domain as domain is going to be the set x such that x belongs to real numbers, but x is not equal to 4 and x is not equal to 2. So that forms my domain of question 2. So question 2 is straightforward. You just do the normal, you equate the denominator to 0 and solve for x, and you exempt that from the set, the set that is going to form part of the domain. So that is just that for question 2. Question 3 is very interesting. Now intuitively, if you are to look at this, we're saying that the denominator is x squared plus 64. Now x is a number which you are squaring this number. Whenever you square a number, if the number is either positive or negative, the result comes out to be positive. So if I've got a positive number and I'm adding it to another positive number, I can say that there is no way that this denominator will go to 0, because let's assume that x is equal to negative 5. This becomes negative 5 squared, that is the denominator, plus 64. Negative 5 squared comes out as positive 25 plus 64. So far as I'm going to get a positive number, when I square this, a positive plus a positive will never be equal to 0. So a positive plus a positive will never be equal to 0. So I can say intuitively that there is no possible value of x in the real number system that is going to make this function to be undefined. Therefore the domain becomes a set of all real numbers. But let's try to solve this and see what we're going to get. Now solving this, to equate the denominator to 0, that is x squared plus 64 is equal to 0. Now I get x squared to be equal to negative 64. This statement doesn't make sense. That is x squared minus 64 is equal to 0, because it's not true. We're saying that we're squaring a number. When you square the number, the answer is a negative number, which we know that the square root of any number is going to give you a positive result, not a negative result. So let's assume that we didn't really catch this one. Let's continue solving this by taking square roots of both sides. X is equal to square root of negative 64. When you input this on the calculator, and if you are not in the complex numbers zone, the calculator will display math error, because this is not possible in the real number system. We can't take a square root of a negative number. So that should tell you that there is no value of x that is going to make this equation to be equal to 0. Therefore, the domain of this function becomes x such that x belongs to the entire real number system with no exemption. So the answer to this is just the entire real number system. Okay, so that is that for the three questions on domain. Let's move on to what we got to do for today. Now, in today's class, we're going to talk about range of functions. If you know how to go about domains of functions, then range of functions shouldn't be anything super complicated. So we're going to start off by talking about the range of rational functions. So range of rational, not just any functions. We've got polynomial functions, but we're talking about the range of rational functions. Okay, so with range of rational functions, first, if we are to go back to relations and functions, we've got the domain and the codomain. Let me say domain and range. So if this is x maps onto y. So when it comes to this, range deals with the y aspect, and domain deals with x. For you to be perfect or very good at range of rational functions, all you need to do is to make sure that you don't have any issue when it comes to change of subjects, because you're going to really use change of subjects at this point. So I'll take a question, then I will use the question to explain what range of function is. So assuming you've got a function f of x, this is equal to 1 plus x over maybe 1 minus x. To find the range, now finding the range, first we set the function to y. So I can say that, let y to be equal to f of x. If y is equal to f of x, then I can write this one as y is equal to 1 plus x over 1 minus x. At this point, I make x the subject. So make x the subject. Okay, making x the subject, I can cross multiply or multiply both sides by 1 minus x. It's the same thing. 1 minus x is equal to 1 plus x. I can expand this bracket. I get y minus x, y is equal to 1 plus x. Now, making x the subject, I can send this to the other side and transpose the 1 to the other side. Y minus 1 is equal to x plus xy. Now factoring out x comes out. I get 1 plus y minus 1. Let me continue over here to that. Yes, so x, dividing both sides by 1 plus y, I get x is equal to y minus 1, y plus 1. Now, if you are very okay with domains of functions, that's where you're going to apply the knowledge of domain. When it comes to range, we're looking at all possible values of y that is going to make x to be defined. So all possible values of y. So all possible values of y that will make x to be defined. Okay, now for us to find the values of y that is going to make x to be defined, it's the same thing as we did when we're finding the domain of functions. To equate the denominator of this to 0, so y plus 1 is equal to 0 and y is equal to negative 1. This implies that when y is equal to negative 1, x is undefined, because the denominator is going to be negative 1, that is negative 1 plus 1, which is equal to 0, which this will end up in division by 0, sorry. I'm going to divide this entire function by 0, which is going to result in the function being undefined. So we can rewrite our domain of the function to be, the range of a function the range of the function to be equal to the set y such that y is a real number but y shouldn't be equal to -1. So this becomes the domain of the question. Like I said, it depends on your ability to change subjects and also a little knowledge on domains of functions. So that is just that for the range of functions. There's not anything super complicated. If you know how to change subjects and you know the concept of domain of rational functions, it's just transfer of knowledge. So let's take another question. Let's take another question to see what we can do about this. So let's take a function. Let me say p of x is equal to 2x over 2 minus x. We have to find the range of this function. So we can start off by saying that we're going to set the function to y. Let y to be equal to the function p of x. If this is the case, then I can rewrite the function as y is equal to 2x over 2 minus x. Now at this point we make x the subject, so make x the subject. Making x the subject, this will get us y multiplying 2 minus x. This is going to be equal to 2x. Now expanding this bracket, 2x minus xy should be equal to 2x. Now taking this side, that is x minus y, or let me say adding xy to both sides, I get 2y is equal to 2x plus xy. Okay. Now I can factor out x. This will get me 2y is equal to x out 2 plus y, and now dividing both sides by 2 plus y, I get x to be equal to 2y divided by 2 plus y. Now to find the possible values of x that is going to make, possible values of y that is going to make x to be defined. For me to do this, I'm to equate the denominator to 0 and exempt the answer I get from the set. So this becomes 2 plus y is equal to 0. Therefore y can be said to be -2. I can rewrite my range as the range to be equal to the set y such that, so you have to take note, domain goes with x and range goes with y such that y belongs to real numbers but y is not equal to -2. When y is equal to -2, x becomes undefined. So this becomes the range of this question. Like I said, it's not anything that is super complicated. It all depends on your ability to change subjects. If you are good with change of subjects, you are good to go with this one. And a small knowledge on domains of rational functions will just guide you to finish up with this question. So the next question, I would like you guys to try. You can pause the video and give it a try. Yeah, we're going to solve it together anyway. So we've got a function. Let me name this function maybe h of x. Yes, let me name this function h of x. So h of x to be equal to 2x minus 5 divided by 2x minus 3. You have to pause the video and give this one a try. Okay, welcome back. So with this one, I set the function to y. So let's y to be equal to h of x. If y is equal to h of x, I can rewrite this one as y is equal to 2x minus 5 over 2x minus 3. Now I can cross multiply. This becomes y is equal to 2x minus 3 is equal to 2x minus 5. Now I can expand. This is 2xy minus 3y is equal to 2x minus 5. Now grouping of like terms, I can get 2xy minus 2x is equal to 3y minus 5, if I'm not mistaken. Yes, I think everything is correct. Now I can factor out x. Factoring out x, I'll get x out 2y minus 2. I think that is okay. Factoring y out, I get factoring x out, I get 2y minus 2. This is equal to 3y minus 5. Now dividing both sides by 2y minus 2, x becomes 3y minus 5 divided by 2y minus 2. Now again we have to set the denominator to 0 to find the possible values of y that is going to make x defined. So there's 2y minus 2 is equal to 0, which just simplifies to y is equal to 1. Okay, so we can rewrite our range. The range of the function now becomes y is such that y belongs to real number system, that is y is a real number, but y is not equal to 1. Okay, so that is that for the range of functions. It's not anything that is super complicated to do. So it's all based on your strengths and changing of subjects and a little knowledge on domains of functions. So that's all for today's session. In the next section, we're going to talk about addition and subtraction of rational functions. So please stay tuned. If this is your very first time of visiting the channel, please take some time to subscribe to the channel and also share this video to your friends that will need this. That's all for today. Stay blessed. We'll meet some other time. This is Matt Fowl. We'll meet some other time.